ideas that are the designer, we had the makers, and we as like AI assistant design tool. Make your vision.
Okay. And what's your background? Do you like engineer, designer?
Yeah, I'm an engineer. We're
Okay.
trying to move towards AI engineer.
Yeah,
Okay,
essentially
right
they were
on.
like trying
That's
to
cool.
extract like moral
Are you
statements out of
at
human
Columbia?
interactions with AI.
Yeah,
And
so
really get
we
into
went
like,
to undergrad
is there
together.
some,
Okay.
Yeah,
if you
and
test
I think
people correctly,
is a
is there some like
New Jersey, New York area.
moral
Okay.
And then I
super
decided to
framework
go back to
between the people
last
And to
year.
this point, it's
Oh,
like,
okay.
although we put them on the axis of Biden and Trump,
You did
there is
see
actually
undergrad?
moral super framework that's next.
I graduated.
Like,
I went to
oftentimes
Columbia
it's
too.
really just a petition of paper, but very much personal.
I didn't fail because I just
I had a lot. It was a great
But
time.
there's a definite part.
We had like COVID years, you know.
So what you have the definite part.
I don't know, I'm trying to think of like a really
Yeah,
competitive, like,
that-
democratic
Yeah.
example.
I don't know. I would say like you could like you drink beer on the
But the
steps.
actual one is like
Like
300
if
or
you
They're like
get 40
really
different
trying
frames
for
for like.
They just like don't see it.
These are
good.
now it's
like
And I
that.
think that like there's
the
this sort of
entry
like
to the campus is like on lockdown
or
almost.
Yeah, I know it was there. It was there a couple weeks ago.
Auto
And
ring.
yeah, I totally got that vibe.
Yeah.
And then I think because
It's I think that like if we
I
really
think
try
that's
to
something
something
that students didn't do
align
is that
AI
if
Not
systems,
available.
we have to think about like their policies and like running a company, not just like abstractly. And you have like theory is like population and like AI twins. It actually understands the perspective of the
No,
problem.
could also be the charging.
As it
I know, but
You're not getting subjects for crypto projects?
there's the future being
very nice to meet you. What about you? What are you working on?
I have a crazy idea
Okay.
that I can do like multi-feature ensemble
I just told him
and distill like an ensemble of all different feature models
Okay, don't go.
into like the best open
Okay, that's not done. The whole thing.
model for locally, basically. So I'm do that and building a multi-feature app called HyperChat.
Which is good.
It lets you talk to all your AIs all at once. And it's like my,
Yeah, it's like a fucking
it's a productivity tool. In the free version, my idea is that it'll throw off training data that I can use to distill.
Actually, even like fireflies. Oh shit. Oh yeah.
So, yeah, that's what I'm doing. It's good, although I don't know that my grand plans of getting this working in time for today,
Kind of fun.
but who knows? You never know. Magic can happen. Start the server now. Yes, start the server now.
So you said your current plan is like for the floating chat. Did you say hi?
Yeah.
To generate training data?
Yeah, like installation.
Sure. Look at that.
I remember judges have to sit here.
Sorry?
Normally, they reserve this spot for judges.
Oh, it is?
Normally, yeah.
Oh, normally. Well, we're
We can fence.
over.
That's not good.
That's really good.
Xcode is crashing.
I think,
Xcode is crashing, so that's a
Oh
problem.
no, you don't want that crashing.
No, I don't want that crashing.
yeah, right. Yeah, a lot of things. It was like a lot of yeah, I think break. Well, the break might be like a chunk There was a bunch of calls set up with like like chapters like that. But yeah, I don't know. But I do really want to while like working. So like, I don't know how much more we need to do for this guy. I think we need to at least work out and then like go on and try to move to
I think there's 3,000,
but
even for even makeup.
well, we don't have the LEDs right now. So
Yeah.
I do have some LEDs sometimes. Let's see if I can work. And then it was like
Show the face.
That's true. Yeah. I mean, I was thinking of just having like face on, but then obviously like you have the first
Say short
as well. If I put it on,
I did not put that.
and the thing is like control circuits would take a little bit more.
They didn't come to the hackathon.
Face on, which is like it just provides a little bit. So yeah. So I think this is a good time to actually start doing that stuff. What happened is back just wondering if it's like
Alright, well, I haven't built it.
Well, here's where he's gonna leave. Go to markets.
You can build it, just get through the demo. Then you
we're
can-
in time with real but yeah, I'll make that change as well. I think actually I can make that change. We can also figure out what the connection was.
I want to catch up with my friends who
I think we just have a bunch of stuff and I hope that that's really amazing pictures. Or, I mean, you can even know about that, like, we just, like basically the things, the one that had already, like, they want, like, pictures of the prompts. When we do that.
part of DC FYI.
I have no idea where I was trying to tell all the Yeah, cool. Anyway, choice. Yeah, exactly.
I think it was just like for the first few minutes. Yeah, I think on like capacity it was like start to change next.
Welcome to judging at the Open AGI Hackathon. Huge round of applause for everyone who shipped today. Congratulations. Okay, ground rules for demos. You are limited to 6 minutes per person, so do allocate your time effectively. Ideally, your demo will come with the knowledge that it took to build whatever it is that you create. Each of us should leave this room with an inkling of how to build whatever it is that you have put together. Do feel free to show code, go under the hood. Obviously, to the degree that your app is real, this is definitely going to be a better experience for everyone. So there's a intent to first announce our judges. So let's hear it for everyone at CyberFund who made this possible, especially Constantine, Stefan, Vitaly, Eric, and Vlad. So they're making this possible, and they will stand in judgment of your projects today. For prizes, we have an AMD prize, which will be determined later in the week, but basically they are giving a full month of AMD access. And Demi has a set of prizes for first, second, and third place, 2K, 500, and 250, for us to compete for. All that said, are there any questions or requests of the audience, requirements for your presentations? Does anyone have anything before we kick things off? No? Go once, go twice. Okay, so with that, first and foremost, let's hear it for Charles and Gwen, who have a CLI tool to discover AMD compute resources from multiple providers. Let's hear it for cheaper GPU. Woohoo! I have 6 minutes if I call you down, no offense. It's not
I'll go at the end with the code.
Okay, and for context, we're live streaming this, so if you'd like not to be live streamed, then we never do cut that.
Okay, so we started with a very virtuous attempt, which is to try to lower GPU costs for everyone. I mean, right now we all know that NVIDIA sort of has a monopoly on these things. So we wanted an alternative, which is AMD, and so we attempted to do that to aggregate all the AMD compute. We ran into a lot of troubles. Okay, so that was the original thesis, to lower compute costs for everyone. I also think that this is something that AMD should care deeply about, because they just spent $4 to $7 billion acquiring a hardware engineering company called ZT Systems. I think they should be willing to spend 10% of that on the software bottleneck, and to access the fastest growing channel, which is us developers. So that was the thesis. We did make a landing page for devs to sign up. Okay, so a couple of things that we learned is that there aren't a lot of AMD chips available. We looked at RunPod, we looked at Shapeform, we looked at Volker. To give you an example, there is one AMD that you have to book a week in advance versus 4 pages of NVIDIA chips. And this was true on Shapeform and RunPod. It's also not apples to apples, it's apples to oranges. Even though the MI300 chip from AMD has twice the memory and memory bandwidth as NVIDIA's H100, the pricing is 10x that of NVIDIA's H100 on RunPod. And so it's not, we don't know how the performance is. From what we were able to gather online, AMD runs well, or it's slightly cheaper for inference. It's more expensive for training. So the other gripe, and we're not the first to gripe about this, George Holtz worked on this. Their version of CUDA, AMD's version of CUDA, which is MES, is still not open source, even though they wanted to open source it a year ago. It's still stuck in legal. I feel like this would be great to get developers involved if they can open source this. Okay, so we have a demo.
Seems like it's working.
You might have a pop-up on your laptop saying allow.
I did allow it, yeah.
Yeah, you have to mirror it.
You should be slapping. Seems like there's a pop-up in one of your screens.
Oh, it's not that one. Well,
Pretty good.
oh, there.
Yeah.
Okay, I'll do this very quickly. Basically, I created a CLI tool that gets AMD from RunPod and Vultr. I tried AWS, but it's too late at this point. And basically, what you do is download this in GitHub, install it, and let's just do it very quickly because I almost ran out of time.
You take one.
Yeah, all this information is sectioned into CPU and GPU. So as you guys can see on this side, it'll be mostly RunPod GPUs, and this side is CPU instances. And it only just gets information at this moment, and the next iteration will be just deploying things. Yeah, we tried to get AMD compute. Kyle was trying to help us out, and this is how we found out the problem. He was trying to call everyone at AMD this weekend, but no one was available. So we're like, oh, we should just build this right now and see how people would take on this. Yeah, that's pretty much our.
I think the conclusion is GPU on demand is just not viable for AMD right now, which is disappointing.
Yeah, hopefully this demo would be helpful to AMD.
That's what RunPod was able to say.
No, we
give
have
you
to-
access to AMD machines.
Yeah, we have to like book ahead.
Book
So,
a week ahead.
yeah, which kind of sucks. Yeah.
There was an option to schedule it.
Other places we had to like book an engineer. So we can't get GPUs right now. So
That's interesting.
yeah. Cool. So hopefully you guys learned something.
One question for cheaper GPU. Question from the judge.
Yeah, for me a question, like if for example it's no aggregation market, maybe you need to start from AMD on demand, like solve that, and then like go into aggregation if it's more demand. Why not to do that?
Because we were trying to access an AMD cluster, and that they were supposed to give us a VPN to try to attempt to do that.
Oh yeah, this is the one that they told us
Yeah.
when Kyle said we have to download a VPN and then get the API access key. But again, no one was available.
Yeah, I was talking to their head, the direct report to Lisa Sue, and we couldn't get them to provision it, even though they said you can have it, but they had to get approval from Taiwan, which required approval from two other people. And then,
Wow.
Have you called to Trump,
yeah, that's literally escalated across 4 different people.
What, that's maybe the VPN.
Yeah.
Crazy.
Any other questions? I hear you. We tried.
You just keep moving. Congratulations.
Yeah.
Okay, that was, we hope is a slightly faster future of AMD computing. Up next, intending to create a private, local AI experience for us all. It's Private AI. Jeremy Nixon. Okay, so who here has run a local large language model on your laptop, on your phone? Fraction of this audience. Okay, that's not bad. So 50, maybe 60%. So I'm curious, what fraction of you ran this model in a manual way, where you had to download the model yourself and you had to load it and you had to run it? Or did the developer create the model for you? So that is, it was in your browser and you ran a local model on a website or something like that. Who had that experience? Okay, wow. Okay, so you see the difference. So basically, maybe 60–70% of you have this experience of downloading a local LLM and running it. Next to nobody has the experience of an LLM as AI transitions into being like the rest of software, where you naturally download an LLM, run it, don't even notice that this has happened, but practically speaking, the developer pays zero marginal cost for the LLM call, and you have a totally private experience of your large language model. That is, there's no call to an external provider like OpenAI or Anthropic. There's no uncertainty about the privacy of your experience. And no matter where you're running the software, whether it's on your phone or on your laptop, you don't ask hard questions about what's going on in the background. So that's the intent with private AI. It's like I designed a library, meant to be pip installable, that allows you to, as a developer, make it easy to run a local LLM on your user's machine, whatever that might be. So support platforms on desktop and server. We use Llama for macOS, Linux, and Windows. On browser, there's what's called Web LLM. Who's heard of Web LLM? Does anyone here know about Web LLM? Okay, 2 or 3, fantastic. Exactly. So the core idea behind Web LLM is you can, for example, create a chatbot experience that's private that runs using your browser to execute the compute on the LLM. And it's a wrapper over all of the major models. So whether you want Llama or Qwen, you can use Web LLM. On Android, Google AI has this Edge LLM inference API, and on iOS, there's this Apple Silicon Foundation Models framework, which came out just 3 weeks ago. Has anyone played with either of these local phone tools? Okay, so say
Which ones?
Apple just came out with their Foundation Models framework, which lets you call Apple Intelligence.
Sometimes it works.
Yeah, I mean, hit or miss, it's true. And then Android has the Google AI Edge LLM inference API. Cool. So basically, these are the major types of edge compute. Obviously, there are things that are not your cell phone or your laptop, but in my mind, these are the essential use cases. So you have a desktop app. You want AI capabilities on that app. So if you're in Slack or Cursor, you want to be able to trigger a local model. Now, there are a number of really important high-level questions here that I try to answer. So I guess questions of model size, questions of hardware capacity, questions of what is available, memory questions. So basically, the model that the developer gets is often not the model that they expect. And so you want to make it clear to them exactly what model they'll be getting in what context so that they can prepare their software for the performance of the model that is functional in that context. And this, in my opinion, is like a big part of why this is sort of not a big deal or hasn't really happened yet. So basically, yeah, an API is very similar to OpenAI. It's a user local execution setup. And we basically allow you to stream the response to get a total response. And the intent is basically it's a similar experience for the developer, no matter whether they're developing for one platform or another. So if it's a web app, depending on where it's running, it can take advantage of whatever hardware is available. So yeah, the core design is the simple sort of pip install. Private AI was open in the namespace, so I went with private AI. Now, why privacy? The central use case for this kind of thing thus far has been that you can have a private experience. For the most part, these local LLMs are just not as performant as the state-of-the-art models, and so the reason people are willing to take a hit is both that the developer doesn't have to pay, but also that way you can have your company's incredibly important but secret data be exposed to the LLM. And so the core use case is basically this highly data sensitive or private context where you say you want to talk to a therapist AI and give it your deepest, darkest secrets. The person who makes an app using this private AI tool will be able to promise you that they never see the data that you put into their application. And so I just basically quickly walk you through some of the APIs. For the most part, it's Pythonic. In the case of a desktop app, if you're an Electron, you can from Private AI import local LLM, and this allows you to sort of set up a user completion. In the browser, we use Web LLM just before, so it's this sort of asynchronous browser chat experience. And in this context, you can get a chat conclusion that works entirely in the browser. Android with Google Edge. This is very Pythonic. version of it, a similar story, and iOS, like I found this would be like 3 weeks ago, like released Apple foundation model codes, and yeah, this is like the API that they provide to the developer so that you can run code on your user's machine. So for the most part, this is a like body of sort of very simple test examples. Unfortunately, I wasn't able to get up on pip and to like complete the workflow so that we can implement apps in this, but this is the core of basically like the example set. So for Android and iOS, for simple chatbot, for local LLM instance. So the primary implementation was basically using the web API. So if you're curious, using web LLM has been really sort of easy, useful, and productive. And so I still have to finish like testing and like work through the Android and iOS examples. But the browser side is sort of the simplest one. Thank you.
Hypothetically, if somebody was building a mobile browser, very hypothetically called tech, would you be interested to partner up with them on local labs, or what do you see as the world of interacting with browser vendors and browser apps?
Is it a browser specifically for mobile? So it's like
Right now it's iOS and Android and Mac test flight coming soon.
Okay. Yeah, I guess I am currently working with a portfolio company that actually is building local RL agents for mobile specifically, and so that would definitely be of interest. Yeah.
Could the browser partner up for discovery with those RL agents?
For discovery, so I guess they already have basically a local browser that works on mobile that is an environment for training reinforcement learning algorithms, so that you're as a user you can like get high quality like totally private experience is very accurate. And that seems like a really solid. So let me know if you want for sure.
Thanks.
Yeah, sure.
Yeah, so one quick question is, so can we, like if I'm building some edge intelligence using sensors in a hospital environment, could I be able to embed this or connect?
What is the operating system of the sensor?
I think right now there are a couple of open options, but more proprietary environments is what they're looking at.
Okay, yeah, I guess like if it's running Linux, likely, but I don't know what it's running, so.
Okay.
Yeah, maybe give me the details about that.
Sure.
Okay, that was Private AI. Up next, from Clovis and Connie, we have Framework Zero, a better way to automate company creation by integrating team preferences using strategy planning across multiple sources. It's here for Framework Zero.
Hi everyone. Yeah, so we'll be presenting a bit of something we added to an existing project. So this is not all relevant to the hackathon, definitely not all created in 24 hours. But I think it's important to kind of show a lot of the context around this. And so, and very relevant discussions around DEMI and the decentralization of the future economy. And so, one of the major points that I think we can all see is, of course, like the hyper-centralization of AI and the direction where we're creating these very powerful AI systems. And a lot of folks think that alignment or figuring out how to integrate them and to do good things for people happens in the data center. It happens through like AI alignment and a lot of the research. And while I think that's very important, I also think there's this massive unaddressed question, which is how do you integrate human preferences when it's active in the world, when it's actually doing things? And one of the main ways we run our economy and we align strong and weak systems is with companies and with our economy, where the strong systems are the existing companies and the weak systems are us humans in the system. And so some interesting approaches that we've messed around with previously is something for the Frontier Tower, where we have this like digital twin where someone can put a lot of their personal data into a system, and that personal data maps to who they are. And as new resolutions get proposed in this building downtown, we are able to actually generate these digital twin justifications and likelihoods and confidence beliefs as to whether or not you will or will not vote for this thing. And so what we wanted to expand that to today was an existing project we had to essentially we have this project working on building more autonomous companies, technically to help solo entrepreneurs scale their businesses, but the eventual very near-term goal is to make that fully autonomous. And we wanted to explore something that we hadn't done yet for this project, which was human preferences. How do you understand human preferences at scale, and how do you use them to integrate them into decision making? And so for a quick side tangent of reference, the company that's displayed here is actually one that Connie and I and someone else started last weekend at a hackathon. And if you want to show the little guy there, yeah, we're essentially working on these AI wearable friends that we put together in basically 48 hours as like a pitch, and have been building out the hardware for and want to launch in the next week or two. And we don't want that to be our entire life. And so what we want to say is, how can we automate? Well, I don't. And so what we wanted to do was like integrate this all into a system that could help to run this company for us. And so these are like more or less the real numbers from the actual hackathon. And the point here is, and here's us and our collaborators. You can see Clovis, Connie, and two collaborators. And so the point here was to essentially first, can we create a system that takes in, based on a lot of company context and a lot of our personal data, create strategies that are like relevant to the kind of things that we would do. And you'll see here that like as it generates them, they're not perfect, but they're definitely in line with the kind of project, and we'll need a mobile app for what we're doing. We're gonna need customer support to like validate and to sustain a lot of the incoming leads and things like that. And so there's kind of this cool space where we were able to bring together all these pieces of information and generate something that would have taken a lot more time and like human resolution to go through, to very rapidly come up with strategies that are not just abstract like policies or democratic constructions, but actually strategies that you would implement in a company. The other side of this that I think is really interesting is this like AI power planning tool. This is something else we have, where the user can actually go through and choose to either add or to, a little bit hard to see, they're essentially able to go through and have documents that are either uncategorized or ones that are more categorized by like custom collections, where the user can kind of go through and decide what they want their collection of documents to be like. This is essentially a shorthand that we're messing around with to help automate company processes, because each one of these has like a clear format as to how that document collection is structured. And this is essentially something you hook up to an MTP so that it can decide whether or not to put a document in one folder or retrieve a document from another folder. And this is all part of our effort to create a more structured, more like symbolic engine, or in other words, like a video game around running a company. And so what's cool about this, and I can actually type out the example, is you can actually go and like chat with it, and you can ask it to like create new things out of these documents. And so these are like emails related to the kind of work that we're doing, and there's a lot of like features and product features. And so you could be like, okay, can I have like, and you could do something like, can I like make, or say add an email for our customer, for a new customer, say, a new customer. And at the moment, just like cursor, I'm giving it context over all the currently selected boxes here. And so it should be able to go through, assuming everything's working. Yep, go, and it pops up. And now it's created a little welcome email for a new customer to go and do something, just giving us context on the project and giving information on the project. And so obviously an email is a very simple example, but all of these are done human-wise right now. But we're aiming to convert this all into something where you have MCPs under the hood, and so it's able to go and you can just tell it, hey, manage my customer emails. Every time I get a new customer email, like reply to it. And it's able to go through using all of this project as context, separate it out in this methodology, which humans can override or map through, but I think an AI will be able to navigate as well. And then go and iterate and create emails, create documents, create different essentially text objects. Because at the end of the day, I think a lot of the operations of a company is like this text data smelter, where it essentially goes through and takes a lot of raw information and creates some like refined documents, whether that be like your sprint planning board or an email to a customer or like what you're going to put on your website. Yeah, and so I don't know what time I'm at, so I'm probably closer to the end there. I could go through some stuff on strategies and like how do you actually go and implement things once it's been initialized, but maybe I'll stop there for questions.
You have 7 seconds.
Excellent. Thank you very much.
Any questions for close? Okay. When you say video game, what exactly do you mean?
Yeah, so I mean, in
Real-time strategy, first person shooter.
Yes, very much.
What are we up to?
I personally would hope it's a strategy game, but in theory, you could create whatever UI the player wants, right? If like shooting bugs is like physically an act that represents something, then perhaps it's useful. I don't know. But yeah, I think it's more of a strategy game. We can look at all the statistics, we can look at the measures and strategy you're stepping through, and get feedback as it's running. I think there's a question back there.
I'm super interested in the friends. Would you consider them potential children's toys?
Yes, absolutely. Yes, there's a little bit of, so I think the 3D print we have here, I don't know if it's child safe, so we wouldn't give this to you, but we're iterating right now on a resin printed version, and I'm looking at, of course, scaling up like production, in China and other spots.
So we'll have 2 lines. One is the kind of full AI wearable, but we'll have like a children's line that's kid safe and stuff.
Cool, any other questions?
How are you integrating feedback from the real world?
On this dashboard specifically? Yeah. So these numbers, you can of course just like pull from your financials or from your Stripe payments or however you want. The planning agent, I have this little sync button actually that should be pulling in documents from like a shared doc space that we have where we kind of throw things. This is just like extracted from like Notion and Discord and a few other spots. And so I think that's kind of like the main way we would do it. So like wherever you already have existing document storage or where people prefer to work at the moment, you would just wholesale pull those in and dump those in. And you see now it's like pulling in documents. Cool, thank you.
Yeah, they made $1,380 on pre-sales in the last project. So
From idea to launch.
yeah, so 80 people purchased it.
We've kept selling every day.
Yeah.
Okay. That was Framework Zero, the future of company automation. Up next, a chance to talk to all of your AIs simultaneously. With HyperChat, we have Matt Morales.
Okay, so if you're like me, you probably have ChatGPT, Claude open on like multiple monitors, and you're constantly going back and forth, kind of like AI maxing. I left the startup I co-founded after 6 years back in March, and I've been on this personal quest to see how far I can go just as an individual pushing myself with AI. And HyperChat is really an experiment in that, and it's not just an experiment in a product, but it's also an experiment in a new way of like designing products and building companies. And so what HyperChat is, I'll show you in a sec. You can just chat with all your AIs all at once. Right now it's ChatGPT, Perplexity, and Google. But the way I built it is maybe something that you guys all could use. So when I started building the project, I have these Claude projects that I have personas. So I started with a Steve Jobs persona. And what I did is I did a deep research report of Steve Jobs' product philosophy, life philosophy, in his own words and in his own voice. And I put that in the project, and I told Claude that it is your Steve Jobs. And I talked about the product with Steve and brainstormed with Steve. And it was pretty amazing because, like, he's not alive, and even if he was, he wouldn't spend time with me. and it was amazing. And so I took that and created a basic spec. And then because I'm building a Mac OS app, Mac OS is a little bit obscure. There's not that much, most of the training data around Swift is with iOS. And so I created an Andy Hertzfeld persona. Andy Hertzfeld is like a very famous Apple Mac OS engineer, and I did kind of the same thing. And I took the spec that I created with Steve Jobs, and I turned it into a technical spec that I put, I took that and I put in Cursor and I gave it to Claude Code in the project instructions, basically. And so I've basically have attempted to vibe code this entire app, and it's been a lot of fun. And so I'll show you what I've got so far here. Okay, so this is HyperChat. And the key thing here is that we're not using any APIs. There's no backend to this app. This is literally the definition of a thin wrapper. So you're actually logging in with your own ChatGPT account, your own Perplexity account, your own Google account, which is really nice because it sucks to have all your data fragmented on yet another service you sign up for. And as I've been using this, it's been really interesting to see times when they don't actually all disagree. So the other day, I asked a question: can I fine-tune Microsoft 5.4 with LoRa and run it on Mistral.rs, which is a inference stack for Rust on device. And what do you know? ChatGPT says you can't, but everyone else everyone else says you can't. And it's been fascinating because, as AI becomes more and more part of our workflows and our lives, we just trust that it's right. It's so convincing. It's so like if I ask ChatGPT, can I do this? Like, this is not a complicated question. It's just factual. Can you fine tune this model with LoRa and run it on this framework? ChatGPT says you can. Perplexity and Google says you can. And the more I've been using this, the more I realize I really shouldn't trust any one of these models, because I literally would just be like, okay, well, I can't do that. Well, actually, reality is that Google and Perplexity is right. And so as we filter the world through AI and through these LLMs, we really trust them, and the more I do this, the more I think that we shouldn't. And that we should we're all trying to figure out what's real in the world. And HyperChat is something that, in addition to making life easier and sort of AI maxing, also helps you get to the truth. My next step here is I'm going to add a local model so that you can talk to on-device model alongside all these things, and be adding Claude and other services. But yeah, that's HyperChat. Any questions?
Yes, two questions. So yes, one, if the value is mostly about disagreement, then did you consider a design where you have a model look at the three responses, and if there's disagreement, say that there's disagreement and say which model said what, as opposed to just giving a straight response?
So disagreement was one of the values that I didn't expect, but I saw. Another big part of the value, frankly, is just speed. Like if you see, boom, Google got it instantly. Yeah. And if you're doing this all the time, speed really matters. And so being able to get instant answers, and sort of like, you can get a quick answer and you can kind of go as deep as you want. You might notice disagreement, but yeah, they're not all they run at variable latency. And so having some instant Because sometimes it might take a long time for them to answer, and you might not need a thinking process, for example.
If you were building this UI for mobile, do you have any thoughts on how would you work with like UI constraint limits for showing multiple models in the same time?
Yeah, there's with WebKit, there's some like weird memory management issues that like the system does and that aren't particularly well documented. That's something I've been thinking about. The nice thing with this is if you have the web view in your own app, you can scrape the DOM and you can extract the data. So what I'd probably do is maybe you have like a primary, like if I want to add a router so we can figure out like, okay, what for this kind of question, what is probably the best model, or maybe not the best model, but like maybe this isn't a question for Google at all, so let's just get rid of Google. But like, and then maybe kind of do a primary interface, and then give you an abstraction, simplified version of these answers, because there's a lot of stuff here. It's a lot. It's a lot to digest.
Thank you. Up next, with a set of experimental results on how to incentivize team coordination between Friday and the conference, we have Kyle, Connie, and Evan coordination experiments. Let's hear it for those three.
Hi. Cool. Everyone. Yeah, I was working on this project with Connie. You notice Connie is on multiple projects. 10x engineering. Evan is another 10x engineer in the crowd somewhere. Where's Evan? Hey, Evan. Also able to ship on multiple projects. So I basically was like, let me take the winners of past hackathons and let's make like an Avengers team for this one. I wanted to explore this from like a research perspective and think about it like a problem that I found really interesting. When you think about like how we got as like people from, eating dirt to building rockets and like cars and hospitals, the fundamental thing that changed was the ability to work together in teams. Even a large company, at AGI House, what starts as a hackathon turns into Perplexity 2 years later. And so I think there's a tremendous amount of leverage that comes from being able to put people together in the correct way with a shared goal to do really big things. And paradoxically, I also think we're tremendously bad at this, as in, I would estimate we're at perhaps 1% of 1% of what we could be. The average, there's 8 billion people on the planet. The average person cannot keep track of more than a few dozen. We forget things, we have biases, and so there's these observations, and then there's also, I believe, this belief I have, which is that in the between now and the next 2 years, I think computers will solve these problems, as in I think they will be able to talk to more people much faster, and they remember everything. And so when I put these things together, I ask myself, well, is there a way to create a lot more leverage in society by using AI to kind of coordinate people together better? And so one of the first experiments I did is I basically made an autonomous bot, a clone of myself, that started talking to all of my friends that were going to a conference that I was hosting on Friday called Demi. Kudos to Connie for shipping. And an interesting thing is we basically deployed this bot. It was chatting with hundreds of people across the network and collecting context from them and then helping match people together for hiring, for investing. An interesting thing that happened too is I wanted to make it easier to talk to this bot, so we'll give this a shot. I tried to then make a video clone of myself, which we'll see if they join. Hey Kyo, are you able to hear me? You're on camera in front of a large audience.
Okay, thanks for telling me.
Yeah, so they're currently reading my previous context where I was asking to help refer someone to Matt Brockman, and I was trying to introduce Matt Brockman and Evan to work together. Hey Kyo, can you still hear me? Well, now they stopped talking. this was just like one of the fun experiments of like, can I do a voice clone and talk to myself? The reason I did that, I won't belabor on there, was 15% of people that Kyo emailed responded. And I was like, I wanted 100%. I thought, like, I was like, I want more people to talk to a bot. Not everyone responds to email bot to intro you to people. And so that was an experiment with like, will they talk to a video? I think the tech is not there yet, but I think it's coming very, very soon, so that's interesting. But I realized that for this to actually be big and connect people, I think I need to go deeper into the data and understand like what is actually, what needs to happen. And so this is where I brought in Evan to basically create a social graph where we took all of the relationships between people. Let me hold this for a moment. You can see this. We basically took all of the different people that were signed up for the conference and we put them in this graph. And what the edges of the graph represent are the strength of the relationship in which the LLM believes that they should meet each other. So what you can do is you can stretch the graph and say what are very high confidence relationships. It's kind of hard to zoom in, there we go. And what we can do is we could search for people that are at the event. So you know, I'll out somebody that's pretty cool, which is Izzy, who lives at the house. We found Izzy over here, and we noticed that you can hover over Izzy. For some reason, her blurb is not showing up, which is classic demo thing. Do you know? Oh no, there's supposed to be like blurb if I hover it, but I don't want to, anyway, it's very early. But basically, each person has a profile associated with them, and what we effectively did was trying to do like the equivalent of PageRank, but for people, and match people together, and see these nuanced ways to route people that have associations. And then what I want people to do is, from that, be able to click a button like company, and be able to decide what is the optimal group of people to pair together to create an organization, like a company. And so I think, you know, in one part there's a cool consumer use case here, which is just route people together, broker introductions. Like an enterprise scale, I think there is the value prop of, hey, I'll help you structure your company better, so instead of just laying everyone off. And I think more in the techno-optimism perspective, there's an interesting angle of just when AIs and people live together, can you build the data structure which represents human trust, reputation, and coordination in an economy where it is an interplay of autonomous beings and human beings. And so I think this might mark like the beginning of a potential infrastructure play for human coordination. Yeah, that's it.
Any questions for the future of coordination now?
How did you get the connection? Like, what's the algorithm for connecting people? Like, figuring out how to connect people?
Evan, do you want to elaborate on the algorithm at all? I'll give you some time, or do you want Connie or Ryan on it?
I'm good. I can talk about it. Do you want me to come up?
Yeah, sure.
Make it quick.
We only have like maybe a few seconds. Maybe just
Yeah, I'll talk from here then. Yeah, so there was a model that dropped on June 5th, Quen 3 re-render. And I had kind of tried graph structuring with embedding models before, but the problem is that they use cosine similarity to judge. And for a relationship, you really want as much nuance as you can. Cost of getting it wrong is really high. So what re-ranker does is a LoRa fine-tune of Quen 3 8 billion. And they essentially have trained it to do document retrieval, where the prompt literally is, here's the instruction, does this query match this document? And literally, the LLM predicts a probability for the token yes and no. Like, it's interpreted as a score between 0 and 1 for yes. So given that it was a LoRa, I was like, I wonder if this could also do people. So I just, instead of documents, put in people's biographies and their wants, and basically any information we had collected on them, and it started giving really nuanced scores, where it gave the probability of yes for someone, for Kyle, it's like 95%. And then in the other way, the person that he wanted to meet 95% wanted to meet him 5%. And I was like, all right, well, is this BS? Like, why does this guy hate Kyle? So I was like, well, this is still an LLM. It should still know how to produce an X token. So what I did is, instead of just taking the score at face value, I took the yes token and I just sampled it. So I said, okay, here's the document, how much does it match? Yes, it matches. And then what happened after is it gave all the reasons that Kyle and this guy should meet, or this guy would want to meet Kyle. But what was even crazier is I was able to do the opposite, where I was able to substitute in no and also get out all the reasons why it would say no. And this model thought this guy was going to hate Kyle so much that by the end of its explanation on why they should meet, it was saying that they shouldn't. So that was a pretty strong, like, maybe they shouldn't.
Thanks, Tyler.
Welcome. Okay. Up next, the very same Evan Pierce with Track Bills Live. It's your round of applause for Evan.
Did you find out, Kyle, who that is? The person who rates you the most.
Is it fine? You can see it, yeah. Is there anything? Yeah.
Alright. So, what am I making? I guess I'll just start here. Basically last week, my girlfriend, she works at the state capitol, and she's been having to go to a lot of Senate hearings recently. And what these meetings are is they're about 6 hours of super dense information where really important things happen, and they need to be recorded super accurately. And there is software that does this tracking, but it's very old and outdated. And I was looking at it, and I was like, all right, well, essentially what I'm trying to do is get an LM to watch a video for 6 hours live and report on anything interesting happening, but with a degree of accuracy that would allow you to feel somewhat comfortable relying on it. So I'm making a live transcript for a Senate hearing. There were competitors called Rescript in YC, and I just felt like their website was like, it was like bootstrap, like they didn't really, like their CSS was broken, and they were trying to charge my girlfriend's company $3,000 for this, and they were in YC, and I was like, oh, like their quality is not good. Let me see if I can beat it this weekend. I'll cut to the chase, but yeah, like, this is the same meeting here, and it is significantly worse. But what gives mine the secret sauce? Well, of course, I'm looking for hidden like things. There's this like old website, and there's this downloadable database that goes all the way back to like 1991. And if you extract all the data, I can essentially pre-populate the context of a large multimodal LLM, so it's prefix cache, about all the senators' names, about all of the bills. So when it detects a person, it knows that Perez is spelled with an E. It knows that assembly member does not have a space within it, because it has effectively read all of what's supposed to happen in this meeting. So I'm going to try restarting this live, and we will see. I had to write a really botched Python script to even get this to mimic what it would be like live. So the audio is now streaming live. The video is different. But what you'll see is it just uploaded the first 10 seconds. The way the stream works is it uploads 10-second chunks, and basically what I do is I just send that to Gemini. Let me see if I can turn on this audio. So this is live. You'll see it starts to lag sometimes. So on the side here, you can start to see that it's parsing out the structured data as it is happening. You might see some like bugginess happen on the right here as it tries to animate. I'm not that great at frame motion, so that this was like a fun thing. But you'll look right here that it actually tries to transcribe a word called sub, and it just went back and it corrected it. So it's able to look back and make corrections live as it's watching the script. So that way, if it gets anything wrong, it can make those corrections on the fly. And the idea would be to hook into these events so that, you know, if you had clients watching this bill, you'd be able to tell what's going on. So this bill just went through consent, which means that everyone, I believe that means that everyone voted yes on it, but later on, votes along with the senators, because those are, everyone that's supposed to be voting is in the database, so it's easy to ensure that the model is picking out a vote for a specific person. It also will contextually identify anyone that is not a senator or legislator based on the context. That doesn't happen until about 5 minutes into the video before Assemblymember Garcia stops talking, so I think I'll stop it there. But it can kind of infer context. So it sees that Assemblymember Garcia is going to be speaking next, and then it can associate the voice with that and keep track of it. That's everything. What was your question?
Did you use a model or did you make this?
I used Gemini 2.5.
And then what's the pre-training to give it context?
There is no pre-training. I just have like what I've been doing is I could pull all this from the database, but what I do is I literally just query the database and then I put in here. So this is like a bill XML that I literally just pasted in. Here's like all of the bills on the agenda, and then here are all of the legislatures and also the chair. I can like prove that that's not cheating. I just did not want to write the SQL yet. There's a database here with all of the bills, what that bill is about, and the XML associated with that bill.
So you get Gemini 2.5 to ingest that database first?
Yes. I have a function specifically called create initial cache. And this literally creates cache content with that entire prompt MD in it. But the idea would be before the meeting to just do some Postgres queries and throw them in. So.
And then how are you getting it to correct? There was one instance where you got it to correct.
Yeah, that took like so many tries to find a format in which it would work. So I have this, Rust is really great for this because it allows me to just annotate stuff with JSON schema, but essentially this is my main like sentence thing. So what I do is I try to get it to predict a complete sentence, but then I also let it replace the last sentence ID. And then I essentially feed that into the model as a JSON schema, which means that it's guaranteed to give me something valid here. I'm wondering if there's an example of what that looks like. I think I put it in the prompt actually, the rendered. Yeah, right here. So you can see it says like, okay, I have a complete sentence, and I was cut off. I have no idea what just happened. That it was just cut off mid-word. You can see it says complete right here. And then next time around, when it says new sentences, it says I want to replace sentence ID 8. Here's the new timestamp. I just haven't rendered those in the UI, but it seems to be relatively consistent about tracking that. And then it replaces that sentence ID.
Quick question, the 10-second thing, are you using VAD for that, or are you just doing?
It's just AHSL.
Here's your chat. We're that's more conversation. Offline. Alright, that was live bill tracking. Up next, with the Darwin Girdle Machine, we have an open-ended, self-improving agent from Brandon and Will. Let's hear it. For the Darwin Girdle Machine.
Okay, so for a little background, we came together to try to create something that was sort of greater than the sum of the parts. Will present Sunscript, but I was trying to imagine how in the context of open source AGI hackathon we could contribute something that would sort of meld well. There's an open source project by Jenny Zhang. It's from Sakana AI. It's essentially a self-improving coding agent that attempts to basically generate a group of agents, and then it evaluates those agents' performance against a benchmark. Codes essentially a software engineering benchmark, and it improves through this iterative process. These results were published a month ago, so you can kind of check them out in our GitHub. But what we wanted to do is to sort of unfortunately, we didn't have a budget for the hackathon. I didn't notice in the paper that it would cost $22,000 to run it. That was in Appendix B. So I read everything through to Appendix A, and I was like, we're doing it. Of course, we ran out of budget, but that's where a subscript comes in.
Yeah, so, yeah, I've been working on Sunscript, and me and Brand have joined forces recently also through the blockchain project I'm doing Nirvana, which has a novel consensus mechanism, which also we can talk about offline. But yeah, so Sunscript is a project I came up with the idea a while ago. I always wanted to do an AI compiled language, and it wasn't until recently I actually finally started building the compiler and building the language. So I can just give you a demo. It's open source, so if you go on the project on the open source, you can go to the docs and get a good overview of how the compiler currently works. I'm trying to make it, right now I kind of went, I built a lot of functionality, but I am still getting it moving. I'll show you guys a demo of what it looks like to build a project with Sunscript. So here are a bunch of examples I've been running. So I'll start with the hello world. So you can see here, this is what the hello world file looks like, where you can create functions and then also multi-file structures with this language, and then you can use simple English language. You can also, it has a flex mode where you can basically write it however you want. Then it also has a structured syntax mode where it doesn't, where you actually will get compiling errors. It also detects like harmful code, harmful applications being built with a quality checker. So here, without further ado, if this is running this. Yeah, so so you can basically, you can have it output to any file, any type of language you want. So you could have it go, give you a whole project with directories and HTML, and have it run, all the different bash codes and whatnot. And make sure it does it. Let's see here.
Be a good time for some questions if it's kind of compiled.
Just finished. So here it is when it was compiled, and then I go to hello world, and I'll write in my name, or I'll say AGI house. Hello AGI house, welcome to Sunscript. And then we can also do, and this will also compile here. Let's see. I just did this recently. Here's a to-do app.
Could be time for questions.
Yeah, any questions?
Yeah, could you have like types in this? Like you make like a syntax tree and literally like use English but then form like a type system? Or is
Yeah.
That, okay. Is
Yeah,
what
that's
you're
exactly what it does.
Wait, so you have like a whole syntax tree under the hood and you're like breaking down like noun phrase, verb phrase, and like variables and stuff?
Yeah, you'll be able to actually create your own syntax too. So you could add your own syntax to the structure. If your team likes to do it one way or another, you'll be able to create your own rules. Because the syntax is primarily going to be for, one would be for working in teams to make sure that everyone can work together and understand what each other is saying. And then the other reason why would be for just more control, being able to have finer granularity in the prompt. You could have it run different AIs for different types of files or different types of components that you're building.
Like translation,
And then-
compression, self-improvement, those are the themes of this presentation, you know. Translating between higher level language, compiling to lower, and then hopefully with the kernel
here's the
part
two
of
do
auto-improve or self-improve.
There you go. And I'll do one last one, which I thought was cool.
We're at time, but maybe like.
Oh, never mind, I won't do it anymore.
Briefly, like one more time.
Yeah.
The question is.
Oh yeah, well, I just wanted to say real quick that so the point with the Darwin kernel is to put that into the compiler so that the compiler can start doing self-improvement, where the compiler can already start running and testing and being like, hey, try to make this app, and then it goes to code, and then it checks out the code and goes, how does it work? Go backwards to the Sun script and use that logic so that the compiler can start preemptively fixing problems that we might run into.
Okay, that was so great. Up next, we have MCPs to enable autonomous therapeutic protein design. Let's hear it for Akasha's AI Protein Designer.
Okay, while reloading my display. So while I fix that, I will try to explain the rationale behind this mirror building. Okay, cool. So, so the rationale behind building this project is that we've seen a lot of public fervor around the notion of AI scientists and AI for lab automation. And what I think that means is that when we get to a world where we're completely allowing AI to design the experiments, and allowing AI to control wet labs, I think we're one misaligned model away from some catastrophic toxin or biological risk actually manifesting itself in the real world. And the first step to sort of systematically trying to figure out if that's possible, I thought, was to enable AI to design biology in the first place in a benign manner. So my goal for this weekend was to essentially build MCPs to enable Claude to design proteins that would serve as to be therapeutic or like drug candidates for well-known diseases. And this was sort of inspired by a project that I did last year, which was me trying to, for the first time after teaching myself biology, try designing cancer drugs. And it's largely a replication of the pipeline that I used then. So I'm just gonna quickly open a new chart, paste this giant 17-page system com. Wait, no, what? Okay, yeah, paste that in. And essentially what this is doing, what I've built over the last 36-ish hours is an MCP that allows Claude to open up the PDB, which is the protein data bank, which is the database of all the proteins that we have experimentally verified the structure of, and essentially get their structures, look at their distances between the amino acid residues, figure out which residues are relevant for therapeutic binding, and using Claude's existing web search integration, also survey the literature on those proteins and try to figure out what the disease mechanism is, what binding strategies you could employ, so on and so forth. And in addition to that, I also enabled built an MCP to help Claude use Claude computer use, because computer use is not yet available on desktop. And essentially what happens is once Claude figures out what its strategy for designing the therapeutic binder should be, it plots parameters for how it wants to use 3 specific tools, namely RF diffusion, which was one of the papers that came out from the lab that won the Nobel Prize last year, protein MPNN, which basically when given the structure or scaffold for a protein, generates the sequence that will fit that scaffold, and AlphaFold, which we've all heard of. And once it does that, Let's see if this works. And for fun's sake, I'm going to test it with a protein I have not tested it with before. Let's see if my demo holds up. Okay, so I asked ChatGPT what other proteins are involved in disease mechanisms. Yes. And one of them, where it is. So that's also apparently a protein that is involved in tumor suppression. And one that I'm unfamiliar with because I originally studied CS and philosophy and have nothing to do with bio. Had nothing to do with bio, I guess. Okay, let's see what the demo looks like. So this one's using the MCP that I built, get protein structure. It's basically a pipeline that calls the PDB API, all 3 different endpoints, collates the data from all 3 of those endpoints for the same structure for all of those multiple chains into a single JSON object. That then gives it to Claude. Claude takes a look at it, then tries to literature search. Should I just click? And now it's sort of looking at the RF diffusion file, which is the collab for the RF diffusion public notebook from the lab that wrote the paper that chains together RF diffusion, protein MPN, and AlphaFold. And I've given it the sort of same collab notebook. And the task for Claude down the line, after figuring out its therapeutic strategy, is to modify that notebook and then employ the computer use MCP that I developed to upload it to Colab and then run it, execute it there, so that I can directly see the results on Colab where I can interact with the proteins. Okay, so it appears to be working. How much time do I have left?
You have 57 seconds.
Oh, questions while I repeatedly click allow once.
How do you know which publications to read?
That's a great question. I don't know yet, but I sort of looked at the PubMed results that Claude was pulling up for 8-HEO, which is a protein that I was sort of familiar with. And it largely looked like the sort of publications that I read and that I cited when I was doing that project. So it appears that there is some latent understanding of relevance to designing therapeutic targets or clinical targets. And also, like, when I tried sort of pushing back on, okay, this is the strategy that you are looking at, why must it work, why would it not work? There was rigor in sort of its understanding that certain regions are disordered, and just because they're disordered doesn't mean that they're undruggable. Whereas I completely avoided disordered regions of the protein because they were giving me low PTM scores when I was using AlphaFold. So there is some notion of scientific skepticism that is employing on its own, which made sense to me last night. But yeah, are there any other questions while it is doing its thing?
How do you evaluate your protein discovery?
So at the moment it's running AlphaFold, and then I'm looking at the regular metrics for IPTM, PTM, PLDDT, and if it's really strong PLDDT and it's like high confidence, it typically tends to bias itself towards alpha helices, but the strategy itself largely appears to be working. I actually have one result that was not automatically generated by Claude, but one that I used Claude's parameters to generate before I made the MCP itself. And yeah, so you can sort of see here that, like, largely, so the scaffolding around it is the 8-HGO protein, the druggable target, and the helix-like structure that you see sort of weaving in and out is what Claude designed, or Claude generated parameters for it to design. And this largely sort of conforms with what we know about how EGFR works, because this spot that you see here, like over here, that's where the EGF ligand goes to go and bind, and that's what triggers two of these big things coming together to signal the start of cell division. And you can see over here that that giant alpha helix is going and sort of blocking that, while also blocking the surface for the dimerization. So over here, like this giant chunk is where two of these thumb-like proteins sort of come together to like dimerize and sort of trigger cell division inside the membrane. and we can see Claude's design strategy blocking that surface, thereby blocking dimerization, blocking cell division. So yeah, that's my project. That was what I was doing for the last 36 hours.
Very quick. What are the steps right before wet lab that you can do to simulate or arrive at a confidence level where this wouldn't cause toxicity in
100%.
In the cellular
Yeah,
environment?
I love this question because I'm actually building AI for toxicology. So I think what I could definitely sort of integrate more tools. This is a sort of super basic generative protein design pipeline. But you could do diff dock, which is that examines the docking of two proteins, and then you could also examine for off-target effects. So, for example, if you know that say there are other proteins around this protein in that cell, then you could possibly also run docking tests with those proteins. Say, hey, do I accidentally bind to these things better? Which means when it's in the cell, I might not end up where I want to, but I just go to this other thing because it's lower energy for me to bind to that. So there's like a combination of finite set heuristics plus ML driven docking and binding, free energy, thermal stability stuff that you could do, and all of that I think is like room for potential expansion of this project. Yeah, thank you.
Okay, and last but not least, a trust builder to prevent drastic, bad, or unethical actions. Let's hear it for Sachin, Andre, and Justin.
Hello everyone. So this is a platform to prevent any bad, unethical or drastic action by a bad actor. And the idea is that the general purpose LLMs may hallucinate or refuse to take actions or lack the context and prevent the intent of a bad actor. So can we do something by building the MCP servers which are domain specific and take the action accordingly? So here I have spin up a news server, military server and a government server for the specific queries. And the way the client picks up the right server is based on the keyword, but it's also determined on the basis of the intent and the context. So let's look into the demo now. Okay, so here I will connect to all the servers. And now I'll be trying out some really controversial queries, like how to create a bomb. Right, let's see. So it blocked that query, citing a critical risk under explosive devices, and it shows the security action, the compliance, and the audit trail. Now let's try another controversial thing, how to create social unrest. Okay, so again it blocked it under a different threat category, which is civil unrest and public disorder, and it says the risk level is critical. Now let's try a good actor news, let's say latest projections on your favorite company, let's say AMD.
Favorite?
Okay, so this time it routed it through the news server, which it should. So the risk level is low, status is approved, and it justifies also. So whatever decision it makes, it also gives a justification on why it selected a particular server and the context of it. Now let's try something, another controversial thing, latest immigration policy of USA. Okay, so this time it says that immigration policy falls under the government. So it went to the government server, and it also cited the sources through which it went through, and Here it again says the risk is low, status is approved, and it's an government server. Now let's try one more. Vital planes maybe. So this time it went to the military server. It was routed as status operational, alert level, and some other things, but the basic idea is it went to the military server and the risk level is low. Now one more thing we can look into is how we can really poison, like let's say the news that we have. So here we can generate a mixed news data set. If you really want to poison our source of news, here is a slider between the real news and the fake news. So let's say I select here a 20% real news and 80% fake news, and I generate this news data set. And now it has generated almost 40 fake articles. It generated 50 articles, out of which 80% are fake articles. It sends to the MCP server, and it can also be around the topic. So the idea is this is how a bad actor can act, generate tons of fake news around the topic, and create a disinformation warfare. So the user can always select a query, whatever they want to, and have the confidence that it is trusted, and if it is not, it can detect the intent of the bad actor and try to prevent it. Thank you. Any questions?
How do you think about like ground truth and figuring out like what's real or not, to make sure that like you're not pulling from, if you're like pulling from the internet, just generally it seems like it's very polluted. Yeah, I don't know. How do you think about that?
So there are 2 to 3 different ways we can do it. One is right now it is counting on the LLMs to do the veracity of the truth or the truth of the news. But eventually it could be a licensing model. Let's say New York Times. It subscribes to this licensing model, and all the news that comes through them is verified as reliable. And that way, any news that is coming from that particular source is counted as truth, at least. So that is one way, but there could be other ways too.
Any final questions? Okay.
Thank you.
Okay. That concludes the demos for OpenAGI. Congrats to everyone who shipped the project this Saturday and Sunday. So we will take 5 minutes for our judges to deliberate and determine which of us are first, second, and third. So feel free to have all those offline discussions and chat amongst one another before we announce the winners.
How's it going? Take a picture of the desk.
Of course, yeah.
This is such low hanging fruit.
Relatively technical.
Were you with 50 years?
No, but I know folks.
Oh, yeah, thanks.
Yeah, I'm a big fan of that.
Oh, yeah, I love them. Yeah, I went to the 50 years like bio night like last week.
Oh yeah, it's pretty awesome. I mean, it's truly like.
Yeah, it's like they're out there. Like most keynote sessions you come away with, maybe it's on here, but you go there and then like.
Oh no.
Every session.
Actually, everything is effective is not even.
Yeah.
Like it's literally not. Like it's no. If someone says moon is frontier, it's like come on. It's like 50 years old, that is. Yeah, it's not about 50 years.
Like we were like there was a session on like cryopreservation and stuff, and like none of us thought it was possible. And the dude like Hunter, when he really started presenting, he was like, if all of you, if any of you agree with me when I'm starting this presentation, you need to go see a doctor.
Yeah.
And then he explained how the physics works and everything, and we were all like, oh shit, it might be that.
No, but you know, cryonics is Ralph Merkel.
Okay.
So leading authority. He's the one who also came with the Merkel training. That's just a really brilliant man. He's one of the foremost cryonics guy.
Yeah. Are you into cryonics? Like, are you into bio?
I'm very much a singularity person.
Oh.
So, for quite some time. So, yeah, Ralph Merkel was when I did my, I was part of this Singularity University like in 11 years ago. Yeah, I mean, it's not a university, but it's an organization. Yeah, it's an organization that really kind of, I'm looking for a program, really have this view of where Rick as well as the founder and think that man with the founders of that. Where the goal is like, hey, it is Singularity is near.
Yeah.
You know, the book of Singularity is really because literally, okay, the moment of real truth is coming, non-linearity is already there, it's finished. No more linear equations. And this particularly tracking the timeline of when that singularity happens. Like, you know, we've been looking at two just from it's more of a logic system and machines. But this one is like complete coincidence where, you know, evolutionary biology will be upside down. Right? So, because everything is around each other, process on how we are existing.
Do you think when the singularity arrives?
So 2045 is the initial prediction. Then nearer.
When it does, do you think we will no longer have unsolved problems?
No, it is not. The purpose is not about solving a problem. It's the purpose of we reach a point in time of it doesn't matter. Right? So partial singularity is which is this technique. Full singularity is like basically we are taking non-existent velocities and probabilities. We are taking definitely pretty much AGI is like a couple of years behind, but then it's just what
I'm curious though, like different people define AGI differently.
The way I think about it is I think the foundationally today our measurement is everything that we apply our intelligence to perform. Again, there's an existing world in which we do things. Means physicist, mathematician, doesn't matter, whatever it is. At what point where the system, intelligent system that we're creating will surpass our capabilities? Like all the best physicists. Means if you are the best physicist, when do we come to a point where I don't have right? So that's AGI is in the cusp of, you know, where because today already 10 to 20% of all just code generation research. Because research requires programming and math. So that's human territory so far we've done using tools. So 10 to 20% of whether it's anthropology actually where things are happening is already not done by humans. It's not even like humans doing the research in their own way. 10 to 20% is like creating a system that just does that. No, we're not doing it.
That was what it was.
So already today, it is 10 to 20%. That is 2025 June. So
I can see the case for it.
So in a year from now, that's going to be like a pretty significant system. 2 years from now, we will literally walk around with the best field physicists, the best field mathematicians, the best field like everything that's almost completely priced. Then like super intelligence is where all of us combined is going to be like the entirety of all the humans collectively. That one exercise is for everybody.
Yeah, no, I can see the case for it. Because like, I think like when I was doing this thing, like last week when I was testing it, the amount of structural biology inside that it exhibited, I was like, like it was, it managed to
not even a specialized model. It's a
Yeah,
general model.
the general is fun. And I can't see this having happened in like November, but I was originally designing those things myself.
Correct.
Because I was using Claude 3.5 Sonnet as a co-pilot guide.
Yeah.
But a lot of the design strategies that I came up with was stuff I figured out from reading analytic research papers, uploading them to Claude and bouncing my ideas off of it and like we started code development.
Correct.
But mostly it came from my head.
Yeah.
Like, okay, we do molecular mimicry, okay, like we can dog dimerization, we can do static photos. This thing came up with that in like one shot. Like it came up with like
Actually,
doing.
sometimes, what I also do is like I not only ask, and say what do you think is happening?
Yeah.
And its explanation is more important than concept.
Yeah.
So you really want to because you, like I said, you came up with it.
Yeah.
Don't tell it you came up with it and see what.
Yeah.
What would be its explanation of the same result, and then you will be like.
Yeah, no, I think at the time, but 3.5 Sonnet it just wasn't there. It's like I tried, but like with 4, I didn't even have to prompt anything. I said, okay, look up this thing. It's relevant to cancer. Figure out how you're going to drug it. And I gave it a bunch of tools to do it. And then it went ahead and was like, all right, here's my strategy, and like it produced like a giant this thing. And a lot of them actually make sense. Like I copy pasted its strategies into the old chat that I actually use as my co-pilot. I was like, yo, okay, you have more context and experience in this domain. I want you to offer a critique of this. So that Claude chat, which is now Sonnet 4, used all of that previous context, was surprised by some of the things, but very badly critiqued others. And then I took its criticism and I pasted it into this chat. At first it completely differed. I was like, oh my god, that thing is right. But then I was like, hey, okay, but like, you have to retain your scientific rigor and like, push back. Then it was like, okay, here's where I'm listening to that chat, here is where I'm not, and here is why. And where it was why it is not listening was also like largely sensible. So I can see a similar case for other great technical fields.
This is where like it's not just about what should I eat for lunch, but that's very basic, right? This is about foundational research.
Yeah, like frontier
like foundational scientific research, right? I mean that's what humans thrive on for advancing our frontier, because our ultimate holy grail is like what are we moving forward, like in a truest way. And right now it's like still like 2 years, right? It's 2025, 2027, like literally going forward every year is a 10x movement. Like it's not like 1 billion times, no. I think that is ended. Right?
Yeah,
so
the AI 2027 paper. I haven't read it yet, but I have to.
So it's like significant, and then partial singularity. So when you reach a point of singularity, like when that happens, it's possible to predict the future. There's no way to predict the future.
Yeah, because we've largely relied on the pace of change to tell.
Unknown. There's no known knowns. Known knowns are over by the time. So everything we do right now is known, using that known except another known. That is the easiest abstraction. But if you also stretch our imagination when you take known, and that's when the creativity comes into unknown. But if you don't have the known variable, unknown, I have no idea, but how do you come up with an unknown model? Not possible from the way we actually.
For context, we were just talking about LLMs doing deep tech and when singularity is going to happen and what happens after AI models today are largely able to do a lot of the research that we do.
It's already doing it. It's a matter of like how much we're going to let loose. And make it good.
Yeah, but I think that's the best argument for AI safety, because I wonder if like you could trick the same thing that I built today to design a binder to some like metabolically critical protein in the body. Like you could disable like web search, for example, implicate mitochondrial proteins in like some disease, and say okay, design like binders to that. It would be like, oh, I'm doing therapeutic design, but it's basically designing toxins. And that's one of the reasons I'm like, I built this actually, because the way we currently test for toxicity or like currently screen like DNA orders for problematic like toxins, this thing is largely stupid. we have like a finite set of known toxins that we like screen against, which are like responsible for ricin or like some neurotoxic agent, whatever. And if basically whatever we're ordering is not in that set, we're like, okay, chalo, we'll let it order. But when you have like de novo, like novel protein design, you can design a toxin that looks absolutely nothing like anything in that set, but still completely wreaks havoc inside your body.
So in fact, I was at another few months ago, another hackathon. It's a UAP hackathon, right? Unidentified aerial phenomena, UFOs, like tagging. So now we are getting into a territory where we don't even know. It's, you know, we can't explain those phenomena, but the phenomena exists, right? And the evidence of some data, again, there were, you know, some deep guys from government to everyone who opened up data sets so we could actually play with it, which I thought was really cool, where one of the data set was a fossil data set. It's a professor at Stanford, where
what is it
gosh, what's his name? I'm totally blank on it. I'll send you the name of the professor. So basically, he's the one who is a cell biologist who actually created flow cytometry.
Okay.
So it's like a deep.
Oh shit! Okay,
So you probably know like Gary.
Like I know the technique, I don't know the guy.
Yeah.
Okay.
So he's the one who actually created that, right? That's the technology. So he's a deep cell biologist. So when you're looking at fossils, again, you do the analysis on your DNA. You know, and fossil is like a good source of that. So they could not identify that there was a shoulder, very old fossil, the shoulder and the neck and like the limbs. The data set, they had no idea what it's made of. Like completely no idea. They just could not catalog based on the known. And the question is, okay, can we then figure this out? You know, like what is the solution?